Morning everyone. Right, today we're going to look at inequalities. Hopefully you'll have come across inequalities in some capacity before. They are sort of what they sound like. Equality and equality obviously is an equal sign. And so an inequality is obviously not an equal sign. Now it doesn't mean the opposite of an equal sign. It means that it's either less than, bigger than, or less than, or and equal to, or bigger than, or equal to. Okay, so we're going to look at what these mean. Now, hopefully you'll have seen these symbols before. They look like this, these sort of crocodile mouths. I'm going to refer to them as a crocodile mouth so that you are aware of what I'm talking about when I say that. Hopefully you remember from primary school that they eat the bigger number. So if you imagine this to be a crocodile's mouth, obviously he's hungry, he wants to eat as much as possible, he's going to eat a bigger number. So for example, we can have that 8 is bigger than 6. Okay, 8 is bigger than 6. We know that to be true. Okay, then we can have 6 is smaller than 13. Okay? Okay, now these two here, so those what those two mean. These two here, they mean less than or equal to, or bigger than or equal to. Okay, so obviously it depends which side you're putting your values. But this one here, if it was this side, it would mean this. Let's say A is bigger than or equal to B. Okay, and then down here we can have B is smaller than or equal to C. Okay, hopefully it'll make sense when we go along. So, we're going to describe these inequalities. Now, in an actual exam, in your GCSE exam, which for some of you is further away than others, in your exam you won't be asked to describe the inequality, okay? But I think it's a really important step that you get into the habit of doing it so that you understand what is happening, okay? So here, we've got x, we've got this inequality sign, and we've got 4. Now, this inequality sign is eating the x, so that means that x must be bigger than 4. Okay, hopefully that makes sense. Here we've got x, an inequality sign, and a 5. Now here the crocodile is eating the 5, so that means that x must be smaller than 5. Okay, now obviously, smaller than or less than, it doesn't matter how you say it. Now obviously you could say 5 is bigger than x, and that means the same thing. Okay, so you can say it either way around, as long as it means the same thing, then that is absolutely fine. Okay, right, then we look at this one. So we've got x, inequality sign 6. Now this inequality sign is eating the x, so x must be bigger than 6. But this extra line underneath makes this bottom look like an equal sign. And what that's saying is that x can be bigger than 6, but it could actually be 6. So x is bigger than or equal to 6. Okay, so if we're going to write some possible numbers, it could be 6, it could be 7, it could be 8, it could be 9, it could be 10, x could be any of those numbers, okay? Whereas here, x is less than 5, it can't be 5 because it hasn't got the equal sign on, okay? So x could be 4, 3, 2, 1, 0, minus 1, etc. Okay, again here, x could be, it's got to be bigger than 4, but it can't be 4, so x is 5, 6, 7, 8, etc, etc. Okay? Okay, let's look here. X inequality sign minus 1. The inequality sign is eating the minus 1. The crocodile, sorry, is eating the minus 1. So x is going to be less than or smaller than or equal to minus 1. Okay. You'll notice it doesn't matter which way around I put the x, but as long as you can work out what is happening. Okay. So if I had 5, that would mean, because it's eating the x is bigger than or equal to, you can say greater than, you don't have to say bigger than, so it's bigger than or equal to 5. Okay, so if we look at this one, x is smaller than minus 1, but it could be minus 1, so it could be minus 1, minus 2, minus 3, because all of those are getting smaller. Okay, here, x is bigger than or equal to 5, it could be 5, so it's 5, 6, 7, 8, 9, etc. Okay. Right, now we look at these ones. These are double-ended inequalities. So we've got an x in the middle, we've got a 2 and a 34 either side. Okay, so x is being eaten by this crocodile, so we can say that x is bigger than or equal to 2, because it's got that line underneath. Okay, but X is not being eaten by this crocodile because that crocodile's eating the 34, so the X must be smaller than 34. Okay, so we can say that but X is smaller than, and it can't be equal to because that hasn't got a line underneath, so it's smaller than 34. Okay, now obviously that makes sense because you can't have a number, there is a number that's bigger than 2 but smaller than 34. Okay, you wouldn't be able to do it the other way around. You couldn't have a number that was bigger than 2, no, smaller than 2, sorry, and bigger than 34, because there is no number that's bigger than 34 and smaller than 2. Okay, right, same here. X is bigger than -3, it can't be equal to -3, but smaller than 10. Okay, here X is bigger than or equal to -1, but smaller than 4. Okay, now you might want to just pause this and make sure that you're happy with what I've been talking about, okay, and make sure you understand how these are working. I'll have given you a sheet hopefully, and that will help you, and that you can practice on that. And this last one, so X is greater than 5, but smaller or equal, oh, -5, sorry, or equal to 6. Okay, right, that's the beginning of inequalities. Okay, so then we're going to move on to the next bit, and the next bit is the sorts of questions you could be asked. What integer values are satisfied by, and you've got a series of inequalities here. Okay, right, keyword, this is very important. You need to write it down somewhere obvious. If you've got your book, could you write it down in your book? I know some of you have left your books at school. Anyway, somewhere important. An integer is a whole number, okay, which means no decimals, just a whole number. And what this is asking us to do is this is asking us to say what numbers X can be. Okay, now you do not need to write all of the stuff that we wrote up here, okay, but if you want to help you, that's fine. So here, X is bigger than -3, but smaller than 2. Okay, which means that, so a number that's got to be bigger than -3, it can't equal -3, so it could be -2, that's bigger than -3, -1, 0, or 1. Don't forget the 0. People forget the 0. It's important, okay? It can't be 2 because it's not got the equal sign on. So when I ask what integer values are satisfied by, that is your answer. The list of numbers that X could possibly be. It's a whole number, okay? It can only be these whole numbers, okay? So let's see if we can do this one without writing this down. So X has got to be bigger than or equal to -4 and less than 1. So it can be -4 because of that. So it could be -4, -3, -2, -1, 0, and it cannot be 1, so we stop there. That's the answer. Okay, here it can be -5 because of this equal sign, so it could be -5, -4, -3, -2, -1, 0, 1, 2, and it can be 3 because of this equal sign, 3, so it can be all of those integer values, all of those whole numbers. Okay, and down here, it cannot be -1, so we first have to start at 0, and then 1, 2, 3, 4, 5. Can it be 6? Yes, because that's where that ends. It can be 6 here. Okay, right, now we're going to go on to, you can pause these as you go, number lines. Okay, right, so here we go. We are meant to be drawing these on a number line now, okay? Now, fairly straightforward. This is saying that X is bigger than -4, less than or equal to 2. Now, you don't need to write that down. I'm just showing you so that you're always thinking, what does this mean here, okay? Right, so what we're going to do is we're going to put the ends of our inequalities on our number line. So you're going to draw a circle above -4 and a circle above 2. Okay, what this says is that X can be any number in between -4 and 2. So we can join that up and say that X is going to be on any of those. Okay, now obviously here it cannot be -4, but it could be 2. okay, because it's got this equals to sign. So to include that in our diagram, we shade in the one at 2, so that we know that it could equal 2, but it could not equal -4. Okay, you don't draw it at -3 because it can't equal -4. You put it at -4, that's your inequality. Okay, so same here, we draw a circle at -3 and a circle at 1. Join them up. It can't equal 1, so that stays blank. It could equal -3. We colour that in. Okay. You'll notice I've drawn these number lines out. If you haven't been given the number lines, you just quickly draw a number line, okay? As long as it's got your 2 side values, it doesn't matter how long you draw your number line, okay? Right, so here we're going to draw a circle at -2 and a circle at 6. Join them up. Can it equal either of them? Yes, it could equal 6, but it cannot equal -2, so we can't draw it at -2. Okay, if they've both got equal signs on, so if I put an equal sign on there, then I'd have to colour this one in as well. Okay, like that. They could both be non-equal to, okay, and then both of them would be non-filled in. Okay, right, now this one's a bit different because this one's only got one number in it, one end. These are 2 double-ended, this has only got one end. So it's saying x is bigger than 4. Now sometimes with these it is easier to write it down so that you can work out what's happening. So we find the number 4 on our number line, we draw our circle, and x has got to be bigger than 4. So if x has got to be bigger than 4, it's going to be this side. It could be 5, 6, 7, 8 up to onwards. Okay, so we say that x is going this way. It can be any of these numbers, but forevermore. So we draw an arrow. Okay, if this was an equal sign, we would colour it in, but as it is, we don't need to. Okay, right, let's look at this one. I've just changed it. So this is saying that y is smaller than or equal to -1. Okay, so that means we can put a circle at our -1. Now it could be -1, so we can colour it in. It could be that value -1. And y has got to be smaller than -1, so that means it's going to be to the left of that. Okay, so it's going to be in this direction. And we can do that with an arrow. It can carry on forever. Okay, it doesn't really matter how long your arrow is, as long as it's got an arrow on the end. It's not an end point. Okay, hopefully that makes sense. Right, the last bit on this, and then we're going to do solving in the next video. Okay, right, so now basically all we're doing here is going backwards. So we've been given an inequality line, and we've got to write down what these inequalities are. Okay, so this is a double-ended one. You can have any letter in the middle. I'm going to go for x, but you can have any letter in the middle. Okay, right, so let's put our x in the middle first. X is going to have to be bigger than -2, but smaller than or equal to 1. So if you always go left to right, you shouldn't ever mess this up. Okay, so we're starting at -2, and x has got to be bigger than -2, so it's got to eat the x, and it's got to be smaller than the 1, so it's got to eat the 1. It can include that, so we put an extra line on the end. That is the answer to that. What inequality is shown? That inequality is shown. That's what you would write down. Okay. Now you'll notice if you always go left to right, then you won't ever mess this up because your inequality signs will always be going that way. Okay. X is bigger than or equal to -2, but less than or equal to normal 2. Okay, I'm going left to right, my inequalities are always going that way because I'm going from smaller to bigger. Okay, right, so same thing again over here. I'm starting at -4, it can't equal -4, so it's bigger than -4 but not equal to, and it's smaller than 1. Okay, double-ended one. Okay, here. Right, so I've got an x and I've got a -2. It doesn't matter which way around you write it, so let's start with an x. X has got to be, if it's going that way, bigger than -2. So x is bigger than -2. Okay, it can't be equal to -2 because it's not coloured in. You could write it as -2 has got to be less than x. Okay, that would work too if you wanted to keep consistent like this, then write it this way, okay? X is in the middle, it's got to be bigger than -2, apart from it's not in the middle in this case. Okay? Okay, and here again, we've got x, and it's going this way, so it's going downwards. It's got to be smaller than 2, so x has got to be smaller than 2, and it could equal 2 because it's coloured in. Okay, next video we are going to do solving inequalities.